Variance of a parameter, a fundamental matrix. If x1, x2, etc. xn a fundamental set of solution of the homogeneous system x dash which is equal to ax on the interval L, then it is general solution on the interval is the linear combination x which is equal to c1 x1 plus c2 x2 plus etc. plus cn xn, or x which is equal to c1 x11 x21 etc. xn1 plus c2 x21 x12 x22 etc. xn2 plus etc. plus cn into x1n x2n etc. xnn, which is equal to c1 x11 plus c2 x12 plus etc. cn x1n c2 x21 plus c2 x22 plus etc. cn x2n etc. c1x a1 plus c2 xn2 plus etc. plus cn xnn. The last matrix is recognized of the product of n by n matrix with an n by 1 matrix. In the other words, the general solution can be written as the product x which is equal to phi of t, which is phi of t into c, when c is the n by 1 column vector of the arbitrary constant c1 c2 etc. cn, and the phi of t is the n by n matrix whose columns consist of the entire of the solution vectors of the system x dash which is equal to ax. Phi of t which is equal to x11 x12 etc. x19 x21 x22 etc. x2n etc. x1n xn1 xn2 etc. snn. The matrix phi of t is called fundamental matrix of the system on the interval. In the discussion of the follow, we need to use the properties of fundamental matrix. A fundamental matrix phi of t is a non-singular. If phi of t is a fundamental matrix of the system x dash which is equal to ax, then phi of t is equal to a phi of t. The expansion of the theorem 10.1.3 showed that phi of t is the same as the Voronskis w of x1 x2 up to xn. Hence, the linear independence of the column of phi of t on the interval regulated and the determinant of phi of t which is not equal to 0 for every t in the interval. Since phi of t is non-singular and the multiplicative inverse phi of inverse t exists for every in t in the interval, the result gives the following immediately for fact every column of phi of t is solution vector of x dash which is equal to ax.